All right, guys, so up to this point, we have talked about rate of change in the starting point. The rate of change refers to how a function is moving and the change of a line. Okay, slope is another name we can use for the rate of change. The starting point of a function is the value that represents the point on the y-axis. The starting point is also known as the y-intercept. So let's take a look at a couple example problems. The parents of the members of a baseball team want to raise money for new uniforms. The parents order team baseball caps and sell them at pep rallies. They sell the caps for $10 each. They pay a design fee of $100 plus $350 for each baseball cap they order from the manufacturer. Complete these tables to show the money they spend for each cap they order and the money they collect for each cap they sell. So the Booster Club caps ordered. Okay, we know they start off at 100 plus 350 per cap. So how much is the amount paid for 0 caps? Well, it would be $100. For 1 cap, it'd be $103.50. For 2, $107. For 3, $110.50. 4, $114, and 5, $117.50. Okay, over here on the right-hand side, we're going to look at the Booster Club cap sales. So for $0, how much did they, or for 0 caps sold, they collected $0. For 1 cap sold, they collected $10. For 2, $20, 3, $30, 4, $40, and 5, $50. So let's write a function rule for the number of caps ordered and the number of caps sold. All right, so for the number of caps ordered, we can do our function rule y equals 100 plus 350 c. That goes directly with this graph here. All right, for the caps sold, going with this graph right here, okay, well, it starts off with 0, so it's $10 per cap, so it's just 10c. So let's take a look at which amount grows at a faster rate, the amount paid or the amount collected. Okay, well, looking at both function rules, we can determine that the amount collected is actually going to grow at a faster rate. I'm sorry, the sold, no, I'm right, collected is going to grow at a faster rate. Why? Because the amount collected has a larger slope. Okay, we can determine this by the 10 and the 350. Which number is higher in front of that variable? The 10, so that's a larger slope. All right, create a graph to represent the data for the amount paid and the amount collected. All right, many of you forgot to put titles on your graphs. Please make sure you do that. Plus, you label your axes. So we're going to go ahead right here, total amount paid slash collected. And then on the bottom, we're going to go number of caps. All right, we can go ahead, start at 0 and go by 2s here. Notice I'm skipping a line every time I do this. Okay, you just have to infer or know that the numbers in between are there. Okay, here we're going to go up by 20s. Again, I'm going to skip a line, so that obviously would go 10, 20, 30, 40, 50, 60, 70, 80. Okay, let's take a look now at our graphs. Okay, so for the amount, we're going to have two. We're going to have a straight line for the amount paid, and you're going to have a dotted line for the amount collected, since we have two tables that we have to be graphing. Okay, so let's take a look at the amount paid. Okay, so the amount paid starts at 0, 100. Okay, and then it goes to 103.50. and then it goes to 107, then it goes to 110, sorry, and then it goes to 114, and then 117. Okay, so if we're going to extend that graph, we know it's going to go out this way. Now, how about the amount collected? Well, it starts at 0, 0, then 1 is 10, 2 is 20, then 30, then 40, then 50. Okay, again, we're going to use a separate line here to represent this graph. Okay, so number 5, we're going to use our graph now to answer our question. Which line on the graph is steeper? Why? Is this what you expected before you graphed the Booster Club data? So which one is steeper? The amount collected. Okay, the slope is bigger. Did we expect this? Yeah, we already answered that question on the previous page, so yes, we expected that. All right, number 6, what is the y-intercept of each line? What does the y-intercept represent in the context of the problem situation? So in the paid, let's take a look up here. And the paid is our solid line. What is our y-intercept? Our y-intercept here is 0, 100. Notice we're writing this in coordinate point form. Okay, what does that mean? So for 0 hats sold ordered, you'll have $100 paid. All right, how about the sold? Okay, well, let's go back up here. Well, here's the sold, or the collected. So your starting point is 0, 0. So for 0 caps sold, you will make $0. So let's go ahead and match the graph with the scenarios described below. Okay, Michael has $25 and spends, so we know we're going down, $5 a week. Which graph correctly represents that? Well, you got to look at either A or D because they're both going down, but which one goes down consistently? D. So that's our answer. So for 8, Julia gains 1 friend each week. Since we're going upwards, it's gaining, you're adding people. Which one is going up pretty consistently? Okay, it's starting at 0 because she didn't have any friends. Poor Julia. But B is our answer. Okay, C, Susie runs to the mailbox, moving away from her house. Okay, well, she's moving away from her house, so if you're thinking about what we did the other day, she's at her mailbox, she stops, so we're looking for any kind of flat line and then moving away from the house. So it looks like A is going to be our answer there. I'm sorry. C is going to be our answer. Since she's running away, we're going up. Okay, Joey slowly jogs toward the finish line. He hurts his ankle and stops before he gets to the finish line. That would be our A. And E, Alex just stands and watches the sunset. Well, Alex, you're lazy, and you get an E. All right, remember, slope and rate of change are the exact same thing. So we are doing the same things we have done in the past, just using a different word to describe it. So how do we find the slope from a table? Okay, a couple different ways. You find your jumps, and then you go y over x. Okay, how do we find the slope from a graph? Up and over, or what some of you are used to, rise over run. So number 12, let's find our slope from the table. So here you're looking for the jumps in x's and y's. Okay, so how do you get from -2 to 4? Well, -2 to 4, you're going to add 6. So how do you get from 8 to 12? You're going to add 4. Now what do I do with this 4 and 6? Well, if you look up here, we know our y goes on top, so our y is here. So we know 4 is going to go on top. Our 6 is going to go on the bottom. But we're not done yet because you have to simplify. When you simplify, it goes to 2 over 3. All right, 13, we have to find the slope of line A. Okay, you can start at either point when you're looking at line A here. Okay, some people like to start at the bottom, some people like to start at the top point. I'm going to start at the bottom point for this one, and then we'll work our way from there. So line A, we're going to start here and go up 1, 2, 3. That's going to go on top. Remember, you always go up or down first. Then left, 1, 2, 3. But since we're moving to the left, it's going to be a negative. So simplified slope of line A is -1. Okay, how about line B? Well, line B is a flat line. Okay, you're not going up anywhere. So your slope is just going to be 0. And line C, let's start from the top point first now. Okay, a little different look. You're going to go down 1, 2, 3, 4. So down, you're going to have a negative. Then you're going to go to the left, 1, 2, 3, 4, 5, 6. And you're going left, so that's a negative. So simplified, a negative divided by a negative comes out to be a positive, so it's a positive 2 over 3. Okay, remember, what is the y-intercept of line A? Okay, this is the starting point of your line. Okay, it's where it crosses your y-axis. So if your y-axis is this big line right here, you're looking for where the graphs cross. So line A, well, line A crosses right here, line B crosses here, and line C crosses here. So let's go look at the bottom. So what is the y-intercept of line A? Right in the dead center of the graph? The origin, so 0, 0. Line B would be 0, 4. And line C crosses at 0, -4. All right, let's try a couple examples here. Find the slope or the rate of change of the given points. It says, hint, make a table. Okay, they give us a table. Here's your x and y. Well, in point 1, 2 is your x, -3 is your y. And 2, 4 is your x, 7 is your y. So in order to find the slope or the rate of change, you got to find the pattern of how to get from x to y. So 2 to 4, you're adding 2. -3 to 7, you're going to add 10. So remember, your y always goes on top, x always on the bottom. Simplify this, you get 5 over 1 or just 5. 15 are going to do the same thing. Let's make your table. -8 and 8 and 3 and 6. Let's find the changes. How do you get from -8 to 3? Well, you're going to add 11. How do you get from 8 to 6? You're going to subtract 2. So -2 over 11, can't simplify that, so that's just your answer. All right. Number 16, after 3 weeks, Cassidy has made $40. After 13 weeks, she has made $160. Make 2 coordinate points. All right, so we got to make 2 coordinate points, then find the slope. Well, our first coordinate point is coming from here. 3 weeks, $40. 3 weeks, $40. Our second coordinate point is coming from here. 13 weeks, $160. Find the slope of the situation. Okay, well, we have our 2 points. It's what we just did. So let's make a table. 3, 40, and 13, 160. From 3 to 13, you're adding 10. From 4 to 160, you're adding 120. So go ahead and make your slope now 120 over 10. Okay, simplified, that just comes out to 12. In 1975, the best calculator in the market cost about $500. In 1980, the calculator cost about $350. Make a table to show this information. Find the slope and use it to estimate what the calculator would have cost in 1970. So here's our 2 points here. 1975 and 350. And you have 1980 and 350. So go ahead and make your table, X and Y. Okay, 1975 and 300. Oh, I'm sorry, this one should have been 500. Okay, 1975 and 500. And 1980 and 350. Okay, let's find our changes. So here you're adding 5. Here you're going down 150. So we have our slope negative 150 over 5. So our answer here is negative 30. Okay, so what does that mean? Each year, the cost of the calculator decreases $30. Okay, but let's say finish our question. What the calculator would have cost in 1970? Well, 1970 is well before this. Okay, so in 1970, how do you think we're going to figure that one out? Well, that's 5 years before, so you're going to go ahead and take 30 times 5, you get 150. So you have to add 150 to your 500. So the calculator in 1970 would have cost $650. Okay, so number 18. Identify both the slope or the rate of change and y-intercept or the starting point. All right, number A, the slope is always your number attached to the variable. So here it's 2.5. Your y-intercept, I know what most of you are thinking, it's 100. No, it's not 100. Your y-intercept has to be in the form of a coordinate point. Okay, and B, the slope, 2 over 3. Your y-intercept is not negative 11, it's 0, negative 11. All right, and lastly in our notes, Jackie is spending, decreasing $25 every month. Okay, she started off with $156 in her bank account. Okay, well there's your starting point. So 156 plus, I'm sorry, minus, since there's spending, 25 per month is going to be their savings. Okay, so the slope would be negative 25, and your y-intercept would be 0, 156. Okay, your homework tonight is worksheet 7. Worksheet 7 is what you need to do for homework.